Hey guys, in this video I'm going to show you another way to make curved lines besides just using circles. And I'm going to use this example. It's like this little drawing my son made that has like a, I don't know, this little something, I think it's like some Fortnite character or something. But we're going to focus on making this curvy shape that falls right along here. So like how we're going to get these little horns to come in here. And so the first thing you're going to need to do if you're doing this along with me is you're going to want to add your own X and Y axis. So the excuse me. This is on page 2. So like we did this one in the previous video, you just need to go to page 2 of the same little picture document. And we're going to talk about how we're going to get this little horn kind of curved effect right here. So even though it's not exactly the same, this is pretty similar to a shape that we call, like if I continue the shape around, it's pretty similar to a shape that we call a parabola in math class. And so what a parabola looks like is right here, so that like U-shaped graph. And so I'm going to show you how to use some basic information about that parabola to get the equation, because we need the equation, of course, to put it into the graphing calculator. And so to develop the equation for this particular shape, again, that's called a parabola, we need 2 pieces of information. The first thing we need is something called the vertex. And the vertex is this spot that kind of, for lack of a better term, is like the middle of the parabola where it like comes out on either side from that middle piece. And we need the ordered pair for that vertex. So because it is right in the middle of the x-axis, that means that the x-coordinate of that vertex is a 0. And then because it goes up 2 from the origin, the y-coordinate is going to be a positive 2. So we've got the ordered pair that represents the vertex. And then we also need the location of just one coordinate on the parabola. And so I'm going to zero in on this spot right here because it falls in here kind of in a corner of the coordinate grid so that it makes it a little bit easier to graph. And because it is over to the left 4 from the origin and then up 4, the ordered pair that is going to represent this particular parabola is -4 and +4. So now that we have this basic information about the parabola, let me show you how to use that to find the equation of the parabola. So I just took a little snapshot of what we had there, and I need to go to my graphic organizer to find a reminder. Well, it probably isn't a reminder for a lot of you guys, but to find the what we need for the formula for a parabola. And so you can see on that graphic organizer, I've given you just the basic, this is what we call the vertex form of an equation for a parabola. So I'm just going to copy that and paste it down here so that I've got a little bit of a workspace. And let's talk about where these characteristics of the parabola fit into the equation. So we need to know exactly what all these letters, these variables represent within the equation. So y equals represents a y-coordinate. Typically, we're going to just leave it as y equals, the same way that we do in slope-intercept form of an equation. You know how it has like y equals mx plus b, so we're going to leave that alone for right now. A, we don't actually know what A is yet. I'm going to help you figure out how to do that in just a moment. X minus is just part of the formula, but the H is going to be a piece of information that we have from our graph because H represents the x-coordinate of the vertex and K represents the y coordinate of the vertex. So I'm going to go ahead and type, kind of backspace, and replace the h with a 0 and replace the k with a 2. And like I said before, we've got to figure out the actual numerical value for a, and we are going to use this coordinate. So we're going to use this to help us do that. So you know that in an ordered pair, the x comes first and the y comes second, right? So I'm going to substitute this y coordinate, so that positive 4, I'm going to substitute in for the y. I'm going to rewrite the rest of the equation here. So got a, we don't know what a is equal to yet. And I am going to take this x coordinate, so the negative 4, and I'm going to substitute it in for x. So that's going to be a negative 4. And then I'm going to rewrite the rest of the equation like so. And so now we actually have a numerical value for everything except the a. So this makes it just a basic equation that now we can solve. So I'm going to do what's inside of the parentheses first because I can simplify that. So negative 4 minus 0 is negative 4. Okay, Annie. Then I need to apply that exponent on the outside next. Negative 4 times negative 4 is a positive 16. And I'm going to bring down everything else. So the a, because that's still kind of like sitting next to that, that means a times 16, and then plus 2 is all equal to 4. So now we're just going to solve this equation like you would solve any other equation by isolating the variable. So I'm going to subtract 2 on both sides. Sorry, that is not a straight line at all. So 4 minus 2 gives me 2 over here. And then I've got a times 16. So to get rid of that 16, to eliminate that in order to isolate the a, we need to cancel out that multiplication by dividing both sides by 16. And so I've got my isolated a that I need over here on this side. And then 2 times 16, or I'm sorry, 2 divided by 16 does not turn out to be a whole number, but that's okay. You can leave it as a fraction. And I'm going to go ahead and simplify this fraction because we can divide both 2 and 16 by 2. So the simplified version of the fraction is going to be 1 over 8. So we've got a value of 1 over 8 for a. Okay, so let's revisit that equation now that we had that we started off with a second ago. So we've got the vertex form of a parabola. I substituted in the 0 and the 2 because that was the x coordinate and the y coordinate from the vertex. And now we just did all that math to find out that a is equal to 1/8. So I'm going to backspace and I'm going to type 1/8. So this is the equation that I'm going to type into my graphing calculator. So I just copied that and I'm going to paste it right here. So I've got a drawing that looks very similar to what I want the little guy to look like with horns. Let me kind of get that over here. We've got a little side-by-side view of it here. So the only problem from an artistic point of view is that, of course, we really want just the horns, right? Because the guy's head, if we look at the picture, is going to be somewhere in there. And so we really want to like kind of cut out this little area here of the parabola so that we only have the little horns coming out to the side of that piece. So we are going to, you probably guessed it, we're going to use constraints to make that happen. So we basically, well, not basically, I'm going to say I'm going to cut it off here. Let me do a better job there. There we go. So I want to cut out that little section of the parabola in order to just make it look like the face is in the middle, and so the horns are coming out. So that means that I really want the parabola to start here with the pieces on either side. So that means that I want it, if I'm looking at the height, I want anything that is under 4, I want that to disappear. So I basically want it to start at 4 and then work its way up. Well, because we're talking about a vertical distance, this is the y-axis, right? So basically, I want this to be graphed for every value where y is greater than or equal to 4. Because I want the horns to start right here at 4 and then just carry on up. So I'm going to add a constraint. And remember, the way that we do that is I'm going to put my little curly Q braces next to the equation. I've got my keyboard down here, so I'm going to hit that. Oh, no, that would be a less than. Oops, I don't want to hit that. I'm going to hit greater than or equal to, because I want my y to be greater than or equal to 4. And so see, it cuts off every value for the parabola that fell under the 4. So there we've got some little horns that we can add, and we can put in, you know, the boxes to make the rest of our picture. So another way, and this is one last method we're going to talk about, another way you could get kind of a curvy line is by doing something that it's called an exponential function. And an exponential function is really anything that has an exponent in the equation. And I'm not going to show you an exact formula. This is one that'll be more for you to kind of play around with. I'm just going to show you the general way that they work so that you can just kind of see what shape you're dealing with. So an exponential function might look, an example is something like this, like y equals x. And to get the exponent, I'm going to hit this little AB button right there. And I'm just going to say x to the 3rd. So notice that it gives you this curvy line that kind of like goes up. And you do have the other version that goes down this way. But let's say that you just wanted to have the top piece. You could very easily fix that by adding a constraint, right? You could say that you just want y to be greater than or equal to 0, for example. And so then it would just give you the parts of that function that are up. Okay, now there, if you type it in this way with just the y equals, you know, the x to the power, they're always going to start right here from the origin. But you can play around a little bit and get it to shift around. For example, you could do this, like say plus 2. So look what happened when I added 2. It took it and it shifted the graph up 2 places. So that's another way that you can kind of get it to shift around. I could have done, for example, minus 3, and you can see that it took the same graph and it like shifted it down 3. So what if you don't want to shift it up or down? What if you want to shift it left or right? Well, then you don't add a number out to the side. You actually change the exponent itself. So I'm going to change that 3. Instead of x to the 3rd, I'm going to say x to the 5th. And then see what happened? Okay, let me go back again. So 3, then I changed it to a 5. See how making the x, or actually, let me show you. I'll just recopy it. Probably be easier for you to see that way. So you can see them kind of side by side. So to make it kind of shift, So see, the black line is the x to the third. So to scoot it over, we increased that exponent, and that's how we got it. It sounds counterintuitive, but to get the graph to shift to the left, which you would think would be smaller, you actually make the exponent bigger. So instead of it being a 3, I shifted it to make it a 5. If I wanted to do another one, so like y equals x to the, you put a 10th. Oh, I forgot. Let's just do to the 11th. See how, once again, it shifts it a little bit closer. So these are just some ways that you can experiment, play around. You can make changes by, for example, you could put a coefficient, you could put a number in front of that, and notice how it makes it a little bit more steep. So lots of ways that you can play around with exponential functions to get yourself a curvy line in order to, again, help bring your masterpiece to life.